In the previous lecture, we have discussed about the definition of a poset and the examples. In this lecture, we are going to discuss maximal and minimal elements in a poset. Let S be a poset. An element M in S is called a maximal element if no other element in S strictly succeeds M. An element A in S is called a minimal element if no other element in S strictly precedes A. Let us take a poset S whose elements are 1, 2, 3, 4, 6, 8, 9, 12, 18, 24. We have to find the maximal and minimal elements of S. Let us construct the Hasse diagram. Here 1 divides 2, 2 divides 4, 4 divides 8, 8 divides 24. 1 divides 3, 3 divides 6, 2 divides 6, 6 divides 12, 4 divides 12, 12 divides 24, 3 divides 9, 9 divides 18, 6 divides 18. This is the Hasse diagram for this poset S with respect to the relation divisibility. Here we see that 1 is an element which divides all the elements, but there is no element in S which precedes or strictly precedes 1. Therefore, 1 is the minimal element. 1 is minimal. And we see that there is 18 and 24. For these two elements, there are no other elements in S which succeed 18 and 24. Therefore, there are two maximal elements, 18 and 24 are maximal. Here you note that a poset can have two or more maximal and minimal element. Let us take another example. the set of integers z with the relation less equals to, this is a poset, and this poset has no maximal or minimal element, has no maximal and minimal element. We know z equal say -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on. Here you observe that if you take any element, then it has predecessors and successors. Therefore, it has no maximal and minimal element. Note, a poset may have no maximal or minimal element. In other way, we can say that if a poset is finite, then it will have maximal and minimal elements. Here is a question which appeared in MACOUT semester examination in 2012. The question is, the set A of natural numbers n with the relationship divisibility is a poset. How many minimal and maximal elements does it have? Option A, 1 minimal and 1 maximal. Option B, 1 minimal and 0 maximal. Option C, 1 minimal and more than 1 maximal. Option D, 0 minimal and 0 maximal. The set of natural numbers n is 1, 2, 3, 4, 5, 6, and so on. The relation is divisibility. Here we see 1 divides all the elements and there is no predecessor of 1. So 1 is the minimal element. But there is no maximal element because any number if you take from n, then it will have successor. Say if we take 5, 5 belongs to n, then there is a number 10 which belongs to n and 5 divides 10. In this way, if you take any number in the set n, then it will have a successor. Therefore, n does not have any maximal element. So, 0 maximal element. Option B is the correct answer. Thanks for watching. In the next lecture, we will discuss about greatest and least elements in a poset.